Hello there and welcome to the series of videos going through the content of A-level maths. Here we're looking at differentiating sec, cosec and cot, and tan as well actually, so we can answer questions from exercise 9f. So let's jump straight into it. How are we going to differentiate tan? Well, the way we're going to differentiate tan is we're going to rewrite tan as sine over cos, and now we've got a fraction, we can use the quotient rule. So, start with your top function being sine. Differentiating that you get cos, and your bottom function is cos, differentiating that you get minus sine. And now we apply the quotient rule. So, differentiating the f function first and timesing it by g, and subtracting the f function times the differential of g. And this is what we get. We get cos x minus sine x times minus sine x all over cos squared. Now we simplify the numerator to cos squared plus sine squared. We all know that that will simplify to 1. So our answer here is 1 over cos squared, and we generally write 1 over cos squared as sec squared. So the answer to the differential of tan is sec squared. Okay, and that is written for you in the formula booklet, so you don't need to remember it, but I'm showing you this because you could be asked to prove that the differential of tan is equal to sec squared, and this is how you would do it. And we're going to do the rest of the trig functions like this as well. So y equals cosec x, we're going to treat that as 1 over sine. So differentiating 1 you get 0, differentiating sine you get cos, and applying the quotient rule, differentiating the f function first, timesing it by g, and then subtracting the f function times by the differential of g, all over the denominator squared, gives you minus cos x over sine squared. I'm going to split that up into minus cos x over sine x times 1 over sine x, and then I'm going to use some trig identities for this. Cos over sine is cot, and 1 over sine is cosec, and it needs a negative symbol in there as well. So your answer to the differential of cosec is minus cosec cot. And once again, that's in the formula booklet for you if you forget it, but you could be asked to prove it, and this is how you would do that. Moving on to the next one, y equals sec. Well, I'm going to rewrite that as 1 over cos and apply the quotient rule. So 1 differentiated gives me 0. 1 was the numerator of the fraction. G, the bottom function, is cos. Differentiate that, you get minus sine. And now applying the quotient rule, the f function differentiated first times g, subtract the f function times the derivative of g, all over the g function squared gives me 0 times cos x minus 1 times minus sine x, all over cos squared. The double negative will turn this into sine x over cos squared x, and once again I'm going to split this up into sine over cos times 1 over cos, and I'm going to use some trig identities for this stuff here. Sine over cos is tan, and 1 over cos is sec. So it's sec times tan. Once again, this is in the formula booklet, but you could be asked to show it, so you need to know where it comes from. And the final one is cot. You would rewrite this as cos over sine. So the f function differentiated gives you minus sine, and the denominator is sine x, so g of x is sine x. Differentiate that, you get cos x. And now apply the quotient rule. The f function differentiated times g minus the f function times the derivative of g, all over the g function squared. And in this case we're going to get minus sine squared minus cos squared all over sine squared. In this case, the numerator can simplify to minus 1, so it's effectively just minus 1 over sine squared, which is the same as minus cosec squared. So once again, the derivative of cot is minus cosec squared. This is in the formula booklet, but you need to know how to prove it yourself. So this here is exactly how it's going to appear in the formula booklet. Tan kx differentiates to k sec squared kx, and the rest of them follow down here. The reason they've got a k here is just in case you've got a function such as y equals tan of 3x maybe. You can use k as your 3 value, So the derivative here, we'll see the 3 pop out to the front, just like the k has popped out here. So it's going to be 3 sec squared 3x. Okay. And the same thing will work for the rest of these as well. Right then, let's have a look at using these 4 derivatives that we've seen previously in the context of a question. So for example, here we are differentiating x tan 2x. This is obviously going to be requiring the product rule to differentiate this. Why obviously? Well, you can clearly see here, and you'll get lots of practice at doing this, that we've got 2 functions here in this combined function that are being multiplied together. So in this case here, one function is going to be called f of x, one function is going to be called g of x, and we're just going to apply the product rule. You need to remember the product rule. It's not given to you straight away, but let's just go through it just so we can see one together. F of x equals x, that's the first function I mean, not the whole function, don't get confused with the notation here. F of x I'm referring to just as the first part of this function. Differentiate it because you'll need that in your answer. The g function is the second part of the function, and we can use the formula booklet here. This will give us 2 sec squared 2x. And now we need to just put it together using the product rule. So the f function derivative times the g function, and the f function times the derivative of the g function multiplied together, and we're going to add these 2 results together. So it's going to be 1 times tan 2x and x times 2 sec squared x. So your final answer here is going to be tan 2x plus 2x sec squared, or x. So there we are, that's this question here, fairly straightforward. Okay, this question here, given that y equals tan to the 4x, find dy by dx using the chain rule. And just a reminder of what the chain rule does. The way we work out the derivative using the chain rule is we differentiate the inside function first, and then we differentiate the outside function second. So what is the inside function in this case? Well, let's think of tan to the 4x as tan x all to the power of 4. So we can clearly see here that inside function is tan, and the outside function is the power of 4. Now we need to differentiate both of these. Tan differentiates to sec squared, and x to the 4 differentiates to 4x cubed. Now the chain rule is this thing here. It's the g function derivative, so that's sec squared, times by the f function derivative in terms of g of x. So this at the moment is just the f function differentiated. In our answer we want the f function differentiated in terms of the g function being tan. So in this case here it's going to be sec squared from the gx derivative times by 4 tan x cubed. G of x is the tan x function, so it's 4 tan cubed. So your answer here finally is going to be 4 sec squared tan cubed x. Okay, one final one then before we move on to some questions of our own. Given that y equals cosec 2x over x squared, find dy by dx. Well, let's go through our 3 rules. Is it the product rule? No. Is it the quotient rule? Yes, because we have a fraction here, which is not the chain rule either. So it's a fraction, so we must use the quotient rule. And we get this from the formula booklet, and I'll remind that of you later. So it's the f function on the top first. We need to differentiate that, and we can use the formula booklet to do this. It's minus 2 cosec 2x cot 2x. The g function is x squared, and the derivative of that is 2x. Now the quotient rule is this thing here, f derivative x, g of x minus f of x, g derivative x, all over g of x squared. So remember, it's the derivative of f first times the g function on the top first, and then it's the other way around second. So in this case, it's going to be a lot of algebra for us to simplify here. Minus 2 cosec 2x cot 2x brackets x squared minus cosec 2x brackets 2x. And then on the bottom it's the g of x function squared, that's x squared squared. And simplifying all of this, let's just move the x squared to the front. It's going to be minus 2x squared cosec 2x cot 2x minus 2x cosec 2x. What I might do possibly is cancel out one of the x's from the top and the bottom here. So my final answer will be, I could factorise out. Am I going to cancel down? Yes, I'm going to cancel down. And I've factorised out the cosec 2x as well. This is a very, very nicely put together final answer. One more then. Let's have a go at differentiating sec cubed using the chain rule. So, just a reminder of what sec cubed is. It's the sec function being cubed. Now, what's the inside function here? The inside function is obviously sec of x, and the outside function is the power of 3. Now, the derivative of the inside function is sec x tan x, and the derivative of the outside function is 3x squared. And now we need to just put them together using the chain rule. So it's the derivative of the g function first, times by the derivative of the f function with the g function put into it, so 3 sec squared. And then put this back together. We can see here we've got 1 sec here, 2 secs being multiplied together here, so we've got 3 secs being multiplied together here in total. That's why we get our sec cubed back again, and the tan x is obviously there as well, so it's 3 sec cubed tan x. Okay, so 3 pages worth of questions here for you to have a go at here. I've got a page worth of product rule questions, a page full of quotient rule questions, and a page full of chain rule questions, so lots of practice for you. Pause the video and have a go at these first 4 questions. Right then, let's have a go at the first question here then. So obviously the product rule, the first function here is going to be x cubed. The derivative of this is 3x squared. The second function here is g of x, which is sec 5x. And the derivative of this function here is going to be 5 sec 5x tan 5x. And now putting these two functions together, so dy by dx, and remember we kind of cross multiply and add the results together, so it's going to be 5, simplifying as I go along, 5x cubed sec 5x tan 5x. So that's the first part multiplied together. The second part multiplied together is going to be 3x squared sec 5x. Great, good. What I'm going to do for the next 3 questions is jump straight to the answer. Hopefully you're following my work process as I do this. So, for the answer for question number 2, I'm going to differentiate the first function and keep the second function the same. Luckily in this case, the first function differentiated is still e to the x, so it's e to the x tan x, and now I'm going to do it the other way around. E to the x is going to stay the same, and I'm going to differentiate tan x, that's sec squared, so it's e to the x sec squared x. And there we are, that's the answer to that question. The answer for the third one is going to be dy by dx, so we're going to differentiate the first function first, that's going to be 1 over x, and keep the second function the same. And then in the second part of the answer we're going to do it in reverse, so it's going to be plus ln x, and then the differential of cot is minus cosec squared. So in this case, when I simplify all of this together, I'm going to get cot x over x minus ln x cosec squared x, and I simplify it all together. There we are, that's the answer to question 3. The answer to question 4, differentiate the first part first, that's just 5, and leave the second part alone, so that's just going to stay as cosec x. And then for the second part of the answer, I need to add 5x plus 4, so keep the first bit the same, and differentiate the second bit, so it's going to be minus cosec cot. So I'll change that positive to a negative, and I'll make it cosec x cot x. Okay, so there we are. Those are the answers to these 4 questions here. Let's move on and have a look at some quotient rule questions. So pause the video and try these 2 questions out. Okay, let's have a go at question 1 then. So we need to differentiate the top function first, that's just e of x, and keep the second function the same, so that's just tan x. Then we're going to subtract the function on the top that stays the same and the derivative of the bottom function, that is sec squared. And this is all going to be over tan squared x. So there we are, that's the answer to the first question. The second question here, we're going to differentiate the top. Sec differentiates to sec tan, sec x, tan x, and we're going to times this by g of x, which is x squared. Then we're going to differentiate, then it's going to be a subtract, then it's going to be the derivative of the bottom one, that's 2x, and keep the top one the same, all over the derivative, sorry, the numerator squared, that's going to be x to the 4. Okay, so that's your answer there. I've done these questions really quickly. I've been just applying the rule of dy by dx equals the derivative of the top function times the bottom function stayed the same, minus the derivative of the bottom function where we keep the top function the same, all over the function on the bottom squared. I've just been doing that as I've gone along. So if you can get to this level here, that's really where you want to be. Okay, the next set of questions here are all chain rule type questions. So remember, differentiate the inside function first, then differentiate the outside function second. Pause the video and have a go at these 4 questions. Right, okay then, so the answer for the first one, the derivative of the inside function is 3x squared. Then we're going to times this by the derivative of the outside function. The derivative of the outside function is sec tan, so in this case here it's going to be sec x cubed tan x cubed. And that's the answer there. The answer to question 2. Now what's the inside function here? Well, what I'd probably think about this as is the cot function that's being cubed. Just make a note of the difference between this function here, where the cubed is on the inside with the x, and here the cubed is on the outside, so it's the cot function that's being cubed. Now the inside function that we have to differentiate first gives us minus cosec x, cosec squared x, and then we're going to times this by the derivative of the outside function, which is the cubed function, so that will give us 3 cot x squared. So our final answer here is going to be minus 3 cosec squared x cot squared x. And there we are, that's the answer to question number 2. Question number 3. Question number 3 is very tricky, right? How am I going to think about this one? Well, I'm going to think of this as cosec 3x plus 2 all being squared. So clearly my inside function is cosec 3x plus 2. Now this is still going to have to be a chain rule part in and of itself. So effectively we've got a triple tiered chain function, chain rule question. Cosec differentiates to minus cosec cot. So the first part of this problem is going to be minus 3. The 3 has come from the derivative of the inside, and then it's going to be cosec 3x plus 2 cot 3x plus 2. This so far is the derivative of the inside, and now I'm going to have to times this by the derivative of the outside. The outside function is the power of 2, so it's going to be 2 times cosec 3x plus 2. So it's effectively differentiated to 2x or 2gx. And then putting this back together, it's going to be minus 6 cosec squared 3x plus 2 times by cot 3x plus 2. So in this case here, differentiating the inside function first got me this far, differentiating the outside function got me this part, and then the final answer mocked up is this thing here. And the final question here, this is a little bit easier than the last one that we've just done in question 3. The derivative of the inside function is tan, so that's going to be sec squared x. And then the derivative of e is just itself, so it's e to the tan x. So there we are, that's the answer to question 4, and have a go at many more questions from exercise 9F. Have a go at all of them, in fact. There's no use in missing out any. The more practice you're going to get, the quicker you're going to be able to do them, the more efficient you're going to be able to do them, and the more accurate you're going to be able to do them as well. So thanks very much for watching this very long video. You've done very well to keep up if you have. Carry on with exercise 9F, and thanks very much for watching.